All right, guys. Let me continue. Let's give a break for. I think you guys must be tired now.
Just sign the sheet.
I signed the sheet. Yeah. No, you haven't. Okay. Okay. Let's take like a 10 minutes break. Okay. Then I will continue this. All right, let's take a 10 minutes break, man. I'm also a little tired. So let's take a 10 minutes break. Okay. So this is what I did. This is what I'm doing here. Okay, this is what I'm doing. This is what I did. All right. Actually, you should look at the website. I've given you a list of formulas. You need to remember. Did you see that or not? It's on the website. On the course website. There's a list of formulas. Be back in 10 minutes. If you have any questions, you can ask me now. Then I will start from this.
抠住抠吗？这样画一下就行。拿那个棉签擦，有问题。是电影，啊，对，我没办法这样。我也是。英国也有。对，英国，但是主要是在那个那个。 我都好久没做梦了。我已经好久没做过梦了。我也是。太累了。太累了。太愁了。就是这样跟我来之前是一样的。我一直都掉头发，所以会出来。我也是，我掉很多。你做过我真的洗发水，掉头发真的变少了。什么洗发水？那个绿色的。97，不是39。我用了大概1个多礼拜吧，然后真的掉头发变少了。不是心理作用，就是刚来的那次使用的那个洗发水，用到会容易掉的。然后用了4、5次吧，就真的掉头发就是不小了。我已经买了2个洗发水，好用好用，还有那个是什么？就是那个因为它第2个半价，我买了2个真的是，我好久都忘不了。
You guys okay?
没用过，我2个才用1年。对啊。还有一个棕色的，就是棕色的，如果是假的，对，另外一个还有这个全绿色的，不是我说那棕色的，我也想买，你看那件衣服吗？
All right, guys, let's begin. All right, can we? Right. So I put this thing here. So a few things cancels. The K and the K will cancel. So, okay. So you have. For the rest, I'm going to write this. Oh, where's my gloss? Now, in the next step, I'm going to change the limit, because at the moment the limit is to W of F. So I'm going to change that to W of G. Right, because that is allowed, because if you look at the question, guys, if you look at the problem sheet 1, you have a copy in front of you, right? It says that you can assume that W of F and the W of G are equal, right? Okay, so that's why I'm doing this. Shit, oh man, that's gonna fall apart. Sorry. Okay, so what you have is the following. You have have this, right? Multiplied by the limit this. Remember, you can take the limit term-wise. So whenever you have a limit of a big expression, you can take the limit term-wise. You know, when I say term-wise, you can say that this is the same as the limit of this multiplied by the limit of this, and so on. That's what I mean. Okay. And then right. So, okay. All right. Now let me ask you: as t goes to the upper end point of g, what does this become? Remember, the upper end w of g is the upper end point of g, right? In other words, I don't know whether you can see me, but maybe. Let's see. Okay, maybe you can see me better now. Right. I mean, the w of g is the upper end point of g. So as t goes to this will go to where? This will go to 1. Remember the upper end point is defined as the value where the CDF is equal to 1, right? So, and similarly this will also go to 1. Okay, and this will go to, both this will go to 1 too. Okay, so what you have is the following. You have, I'm going to combine these two. So what you have is that this is equal to the lim multiplied by the lim Okay. Are you okay? You following me so far? So you see that since both these go to 1, this term disappears, and since both these go to 1, this term disappears. So the only two terms that you have remaining are this and this, right? Okay? All right, the next step. The next step is I'm going to use star. You may remember what star is. Do you guys remember star? It's this one here. Can you see this? This star is that the limit of this is equal to EF minus x, star, right? So I'm going to use star. So this will become the okay, and multiplied by EF minus x power b minus 1. Okay, just by star. So let me take this and put it here. Okay, all right. So now the next step, I'm gonna use the you see, I have used, in this step here, I have used the L'Hopital's rules one more time, but in the reverse direction. So if you apply the L'Hopital's rule, I should say I have used L'Hopital's rule in reverse. In other words, if you apply the L'Hopital's rule to this one and this one, you will get precisely what is there, right? So if you differentiate this with respect to t and this with respect to t, you will get what is here. Okay, so that's what I mean by the LH rule in reverse, right? Now in the final step, well, close to the final step, I'm going to use star again, so it becomes EF minus x, and this is multiplied by this, so it becomes EF minus bx, which is of the same type. Right? So this is how you will prove that. You see, it looks like a long process, but it's not really. I mean, once you get used to this, it will not be difficult. So what we have done, just to summarize, what we have done is to assume over here that G belongs to the Gumbel-Max domain, which means that there exists a function gamma t such that the limit is equal to this. And then we have shown that f also belongs to the Gumbel-Max domain by showing that the limit of this is equal to this, which is of the same type as this, right? So hence f also belongs to the Gumbel-Max domain. So this only proves part A. The arguments are similar. for B and C. Because remember, there are three parts you need to do. In order to show this, you need to show three things. Where did I write it down? I wrote it down earlier, just a minute ago. I wrote down, trying to find out where it is. Did you guys copy that down? Or no? Where is it? I'm trying. No, it's not here. You remember that I wrote down there are three things you need to show in order to prove this result. Where is it? Where is it? It's gone. No, where is it? I can't find it. Did you guys copy that down? The first thing I showed you. No? You did? Huh? Come on, guys. You didn't copy? Come on, guys. No, it's here. All right. This is what I said. To do question 11, you need to show three parts: A, B, and C. Right? A is to assume that G belongs to the max domain, the Gumbel max domain, and show that F also. And part B and C are similar for the Frechet and the Weibull domain. So what I've said here, the arguments are similar for B and C. So I will leave that for you to complete. Right? So you just follow the same arguments to do part B and part C. Okay? Alright guys, so let's go back to the problem sheet now. Which problems you haven't done? Can you tell me, like, of the 14 problems, I have done question 11. So let's say, let's take this. I have done this. So which are the problems you had problems with? Or you had difficulties with? Huh? 3. One, the variance of 3. Yeah. Okay, any other problems? What about you, sir? You've done all of it? Okay, so I'm showing you how to do 11 now, so you should be okay. How do you know? How you guys, which of the problems do you want me to do now? Like the difficult ones?
I didn't know how to integrate.
Which one?
23.
2.
To find the mean and to compare.
Okay, alright. What about you guys here? Any of the questions you have problems with? Sorry. 2. 12 is similar to 11. So I showed you how to do 11. So you should be able to do 12. Similar. You guys? Any question? Any of the difficult ones you want me to do? 13 I just did in the class right now. 13 is just what I did in the class. 13 is to find this is the quantile function. This is the quantile function of the GEV. I showed you how to do that in the class earlier today. You were there, right? I'm sure you were here. Didn't I show you guys? I can show you again if you want, if you forgot. Come on, guys. You were here. Where am I? This question is just finding the quantile of the GEV distribution, which I showed you a minute ago. Not a minute, a few minutes ago I showed you how to do it. I thought you understood it. Let's see, let's try to find out. Yeah, it's here. It's this one. It's this one here. This is what I did this morning. I mean, this just an hour ago. I showed you how to do this. So all you have to do is you just set this. You set the GV. This is the CDF of the GV equal to P, and then you solve for XP, and it turns out to be this, right? So this is the same as question 13, right? Question 13. Did you guys follow this or not? Did you understand this process or not? Do you understand this or not? I can go through this again if you don't. You do? Okay, thank you. Okay, thank you. Good. Okay, let me, some of you guys told me what? Question 2. Let me try to do question, okay, let me try to do question 1 first. Question 1, okay? Question 1 is to find the density functions of this and this. So lambda of x is the Gumbel density, which is this, right? So the density function of this is what? It's gonna be this, yeah? Yeah, and then phi, this is equal to, what's the formula? I forgot. Do you guys remember the formula for this? What's the formula for, I forgot the formula. Come on, guys. Here we are. So the formula for this is 0 or e minus x to the power minus alpha. 0 if x is less than 0. Okay. So if you take the derivative of this, guys, yeah, you get 0 if x is negative. And you should differentiate this with respect to x. You get alpha x power minus alpha minus 1 . Okay, this is what you get. Is that right? Okay, correct me if I'm wrong. It's possible that I get things wrong. Okay. And the next one is the Weibull. So you should differentiate this. Now, what's the derivative of this, guys? Minus. Come on, guys, think. It will be what? Alpha minus x power alpha minus 1 e minus x alpha if x is negative, and 0 if x is, okay. So this is question 1. Okay, are you guys okay with this or not? It's easy, right? With question 1. Now question two is, what is it? Question 2 is to find the mean. To find the mean, what do you need to do to find the mean? Guys, how do you find the mean?
Let fx be 0.1.
Come on, guys.
X times the PDF.
Sorry. Where's my paper? I'm not a paper. So you just integrate the PDF, right? All you have to do to find the mean, you just simply integrate x times the PDF. So I'll just do it only for the Gumbel case, and the remaining are similar. So this is question 2, guys. We know that the density is this. This is the density, right? So to find the mean, all you have to do is you just integrate from x multiplied by okay, this is what you do. Okay, now how do you integrate this, guys? You need a substitution, right? So this is where your calculus, I'm sure all of you are experts in calculus. So I'm going to do a substitution. I'm going to set y equal to e of minus x, right? So x equal to minus log of y, okay? And dx by dy will be minus 1 over y. Okay, so under this substitution, the integration will become, when x is minus infinity, this will be plus infinity. When x is infinity, this will be 0. So x will be okay. All right. Are you with me so far? Let me know if anything not clear. Now I'm going to use the minus sign here to switch the limits around. So it's going to be minus 0 to infinity of log y multiplied by e of minus y dy. Now, any ideas how you can work this out? Yes, sir. How do you do this integration?
By parts. Okay.
All right. Let me ask you a question. If you have y to the power a and you're differentiating with respect to a, what is it? What's this equal to? Y power a log 5. Okay. You know this formula, right? Yes. You must have done this in first year.
Yeah.
Come on, man. Alright. So you put, now I'm gonna do, you should put a equal to 0 both sides. I'm setting a equal to 0 on the left and the right. right? So this becomes and the left hand side here will become what? If you should put a equal to 0, it becomes log of y, because y to the power 0 is 1, right? Okay, so let me put this in a box. You're going to see a lot of boxes. So what I'm going to do now is I'm going to replace the log of y here by the right hand side. Sorry, the left hand side I mean. So you get d which is the same as minus. I'm going to take the d by dA outside the integral. Then inside the integral we have y power a plus 1, right? Okay. So do you see what I've done? I've substituted log of y in place of log of y. I put this guy here, which is the left, which is this thing here, right? And then I took the derivative operation outside the integral, and also the limit a equal to 0 outside it. Now this integral here, you must know what it is. You should have done statistical methods. You know this integral. You've seen this before. It's a gamma function. You seen that, sir? No? It's a gamma function. I will show you. I will write it down in a minute. This is the gamma function at a plus 2, sir. Oh shit, man. Sorry, I made a mistake. You didn't see what the mistake I made. The y and the y, okay, let's go back here. The y and the y cancel out, right? So this shouldn't be here. Okay, so this shouldn't be here. And this should be a. This should be a, not a plus 1. So this will be gamma function at a plus 1, right? At a equal to 0. So the answer is minus. This is the answer. Do you guys see this or not? Yes? Alright, now if you don't know what a gamma function is, I know some of you forget, I will write it down. I will write it down over here, guys. A gamma function. I will. Okay, a gamma function at alpha is defined as the integral from 0 to infinity of t alpha minus 1 dt. Okay, this is the definition of gamma function. Alright, this is the gamma function is defined everywhere except at 0, minus 1, minus 2, etc. Some properties of gamma function are as follows. So the gamma function at n plus 1, where n is an integer, is the same as n factorial, right, if n is an integer. Okay, and the gamma function at a plus 1, where a can be any number, is the same as a times gamma at a. Okay. And another property is that the gamma function at half is equal to root of pi. Okay, so these are some properties of the gamma function. Okay, you may want to know this, but I will put it here if you want. So this is so in the penultimate step, I have used the definition of the gamma function, which is this, right? So to go from this line to this line, I've used this definition. All right, guys. So, any other questions you'd like me to do on the problem sheet? So this is question 2, right? The question 3 is similar to this. So you should be able to do question 3 based on this, right? Now, any other questions you'd like me to do? Or is it okay? Let's come in at this one. We try this. Okay, I'll do it. Okay. All right, let's do question 10. Right. Right, the first thing you need to work out is W of f. Right, so you put fx equal to 1. So this implies that 1 minus is equal to 1. And this implies that k of is equal to 0. So this implies that, this clearly implies that x is equal to plus infinity. So W of f is equal to plus infinity. So you can start checking by condition 1, but I'm sure condition 1 will not be satisfied. Right? I mean, I'm not trying to cheat on you, but if you check condition 1, condition 1 will not be satisfied. Okay? So I will start with condition 2. Condition 2, what is condition 2? It's the limit as t goes to infinity of 1 minus ftx divided by 1 minus ft. Okay? Yes? So we need to show that the limit of this is okay. So the one cancels. So you get this is as the limit as t goes to infinity of and this is equal to x to the power minus a. Right? So what's the conclusion then? What does it mean? It means So by the ETT, approaches 0 or EF minus X minus A if X is less than 0, if X is greater than 0. Alright guys, it's not difficult, is it? Any other questions you want me to do? So that's number 10. Yeah, okay. You guys okay with and do you have any questions you'd like me to do? No? What about you guys?
No.
You sure? Yeah. This goes to 1 because W of G is the value of G where E of G equals to 1. Remember W of G is like 20 function of G. Yeah, that's right. Yeah. So it must be 1. T equals this, that would must be 1. It's the same here because gamma T is a positive number. Gamma T is a positive number. So T, anything added to W of G will also be that one as well. So it must be 1.
For every exists.
Yeah. Yeah. Because you can't apply the same argument here because then we have 0 divided by 0. This is problematic. So you can't apply it. But you can apply the star. Then called star. Right? The star. Then when you come down here, when you come down, when you come down here, you can apply star and say that this is equal to this. Yeah, because this was the 1. You have questions? Because exactly G is the point where G of T equals 1. Alright, let me explain. I think several of you asking the same question. Alright, when I did the earlier question, is it question 11? In question 11, guys, you may remember that I said this. I said that as t goes to, can you listen please? As t goes to W of G, G of T goes to 1, and this also goes to 1. Did you understand why exactly, or no? Yeah. Did you follow why it's the case? Because, okay, let me explain again. Because by definition, okay, let me put this here, right? And let me try to explain that over again. By definition, W of G remember, I talked about this last week. W of G is the solution of this equation, right? That is G of WG must be equal to 1, right? Okay, so if you take the limit here, if you take the limit as t goes to WG, then this guy here must be 1, right? You guys follow me? Yeah. And the same applies to the numerator because okay, this will approach G of okay. So as t approaches WG, this will approach this one, right? But we know that the gamma function, we know that this guy here is a positive function. Gamma is a positive function. I mean, that's one of the properties. If you look at the notes I gave you last week, the gamma function must be, the little gamma function must be positive, right? And x is also positive, right? So therefore, what you have here must be greater than or equal to G of WG. And this we know is equal to 1. But nothing can be greater than, because as you know, any CDF must take values between 0 to 1. I mean, you cannot have a CDF that is greater than 1, right? So this implies right? That's okay. This implies. Do you follow my argument? Because I mean, this argument here says that the limit of this must be greater than or equal to 1. But you can't have a number that is greater than 1 because probabilities must be between 0 and 1, right? So okay, and hence this must approach 1 as t goes to WG, right? Okay. So that's the argument that I used here over here, guys. That's the argument I used here, that G of t approaches 1 and this also approaches 1. So 1 divided by 1 is 1. And the same thing here. G of t approaches 1. This also approaches 1. So these two cancel out. Right? Okay. Alright, guys. Any other questions you'd like me to do? How much time? Oh, we have run out of time. Okay, guys. So I'll see you next Monday. But you know my office, right? You know where to see me. So any questions you guys have, come and see me in my office or send me an email, or you can Zoom me. I send you a Zoom email. Did you all get it? Yeah, you can Zoom me anytime, 24/7. Okay. All right, guys. Have a good day. Oh, have a good night. Yeah. This is quiz 1. Okay, thank you. See you next week or whenever. Yeah.